Pikachu, I choose you.
Greetings, the Astro 30 here yet again, and welcome back to AEL. If you're new to this channel, please go down below and subscribe if you haven't done so already. Cheers. Got another kit to build today. It's Short Circuits Volume 3, Project 2, Ding Dong Doorbell. Now, I have done a circuit before on the channel. I think it was based on this one, I'm not sure. I have to go look back at the footage. But I'll put a link at the top here so you can go look at that. This is based on a 555 timer. And it says, ideal for the front door. This project generates the sound of a classic ding-dong doorbell. Kit includes PCB, speaker and all components. It requires 12 volt DC. Use project 28A. I'll have to investigate that. I think it's just a universal regulator. Instructions, obviously you've got to buy that separately. I've got the PDF to look at, that's fine. Optional UB3 Jiffy box. Instructions not included. A bit like back in the 80s where it used to say on kids' toys, batteries not included. So let's open the thing, get rid of that. Here's their preamble, useless crap, just promoting Short Circuits Volume 2 and 3 and I think 1 as well, yes. So we don't need that, piece of crap. We get the components, solder, nice. One of these little spickers, so that's going to be fun to solder to. And of course the PCB, which is again oversized for no reason. So there's a good look at it. It uses a 20k variable potentiometer here to change the sound of the tone that it generates. And we'll look at the schematic in a minute. I'm not sure why J-car PCBs have these extra 2 holes, or 3 in this case, 4 in this case, just drilled randomly anywhere. Not sure what the purpose of those holes are. But yeah, uses an NE555 timer. I want to see if this will run on a 7555. It probably will. Has 4 PCB stake points, and they include the PCB stakes, which is good, and just a few miscellaneous components here and there to make a stable oscillator work. So let me pull up the schematic or instructions. Right, so here we go. That's the project number 2. All the components mount to the board. I'm probably not going to mount the switch to the board. Well, I probably will to test it, but to make it a doorbell you need a remote switch. But that's okay. Here's the schematic. So what we've got here is it's a 555 timer. So power comes in here, goes through, stop doing that, goes through a half-wave rectifier, or wrong way protection diode, and we've got an stable oscillator over here, and this transistor here, when you push the button, it changes the duty cycle or the control voltage on pin 5, which will give you the higher tone, and when you release it, then the tone will lower, because then we've got a discharge path now through this 100 microfarad capacitor into the reset pin. And it's basically just an stable oscillator made up of these 2 resistors and that 0.01 capacitor. The loudspeaker is connected via a 100 ohm and a 10 microfarad capacitor directly to pin 3. So the purpose of this diode here is when the push button is in, well, we're applying control voltage to pin 4 to actually start the oscillator oscillating. And as soon as we push the buttons released, well, it discharges through this capacitor into pin 4 to keep it still oscillating for a certain period of time with a lower tone, and then when the voltage drops off and reset becomes close to ground via this 1K resistor, the oscillation will stop. So that's basically the operation of this circuit. It's not that complicated. So I'm going to build it up and we're going to test it. So I'm going to build this whole thing up in time-lapse. I'm just going to have to look at some of the resistors here to see what value they are first. And because there's two 10Ks, two 100Ks, 2K2, a 1K and 100 ohm. So I just want to make sure that I get the correct resistor sol in the right spot, so I'll just measure them just to make sure. The switch, be careful of that, that does have a certain orientation. There's a little notch here at the top of the board, so the notch would match with the notch on the push button, because this can fit one of four ways round. So if you get it 9 degrees out, it'll be permanently turned on, because of the way the contacts are wired. You'll just end up shorting these two connections out, and yeah, the circuit will be functioning and making a noise all the time, which is not what we want. So I'm going to start with the PCB pins, and yeah, just go to resistors, the variable power resistor. I'm going to install a 8-pin dual inline IC socket so I can change out the ICs. But you don't have to, you can just solder the 555 in directly. So, alright, let's go. There it is there. Took about 18 minutes to assemble. Now if you're wondering why the capacitors are bent over flat like that, it's because this is designed to mount in a case like that, so that there'd be the top, the button sticking out, and the capacitors are just too high. It may still be too high with the IC socket in there too, but that can always be removed. I did run into one issue. The 1N4148 diode was missing. So luckily I had stock of those to replace it with. I don't know where it went. It's not in the bag, so who knows. I'll have a look at what I just threw out, but I'll stick the IC in there. Like that. Well, it may not be too high. So they give you a little bit of speaker cable here for the speaker, which is great. I've used the on-off switch, raised him up a little higher so we can get some clearance with this speaker as well, because it is quite proud. I mean, you probably wouldn't screw to the switch. You'd probably just use standoffs and then mount it to the top of the case, and then probably glue this convoluted looking thing in there. So or you make this a remote speaker, one of the two. So this is the speaker they're using. It's just basically a plastic diagram. There's the voice coil in the middle there against a permanent magnet. So this is not high quality hi-fi or anything. And it just connects to these two solder pads at the back here. That's the permanent magnet. I'm not sure what that is. It's got a code written on it. Oh, it's 8 ohm quarter watt CPC. So in order for this to produce sound, this is going to have to be soldered. What the hell is that? Don't know if you can see that, but look at that piece of fluff or crack that's on the actual inside of the speaker there. It does move around. It's probably gotten in the holes at the back here. Yeah, I've got it now. It's on my finger. It's just crap. Right, so with that crap removed, because it'll just rattle around inside there if I don't remove it. It's marked positive there, negative there, so it's positive on the left, negative on the right. So I'm just going to strip back a bit of this cable. Fuck off! Right, it's always a good idea to use the proper tools if you've got them, instead of screwing around with side cutters. I think that was probably the wrong hole, so I'll be the next one up. There we go. I'll strip both ends whilst I'm at it, because I don't want to connect it to the speaker and then have to strip this end off to connect it to the board and putting stress on the soldering pads. And then I'll set up a power supply in a second and we'll see if the bloody thing works. Which it should. This solder smells funny. I'm not sure if it's lead free or leaded, but it does have a funny after smell to it. Right, so I think I can solder directly to this. Yes, I can. Great. Find the black lead, which is there. That's one. Can't believe the signal diode was missing. It's unusual for a J-car kit for having components missing. I have never built a kit that's actually had a component missing before. Solder that one to there. Right, now the speaker is connected. So, get that to go over that way somewhere. Let me get some power supply leads and clean up a bit, and we'll then test it out. Found it. It was actually my error. It was still in the bag and I threw it in the bin. So yes, the diode was included, but I had spare stock anyway, so I'll stick this in my junk bin with the others. Okay, the thing's connected to the power supply. I'll just drop this back to 12 exactly. 12.2 close enough. Turn it on. Ooh. Ooh. Very quick. Let's adjust this potentiometer. It's not very long on the discharge. It's also not very loud. But it works. Nice. Turns off. Alright, let me pop that 555 timer out and replace it with a 7-555 and see if it works the same. Oh, what's the current draw? Very naff old. So I should probably connect that to the multimeter to actually measure it. Alright, so let's connect that in its place. you over there, connect you to the negative lead of the multimeter, connect the positive lead to the positive of the power supply, milliamp AC DC. Alright, let's turn it on. We can see that we've got like 10 MA of current draw there, which is considerably, well, that's pretty much normal for that 555 timer. Up to 42 MA when it is oscillating. So I will change that IC out. God damn. Pull this one out. Maybe sometime today. Gosh, that's in there. Oh man, that was in there tight. That's what she said. I'm going to put the 7555 in. Like that. It's going to be fun to get back out. Put it back on. Well, it operates, and we're now down to 4 MA. So there's a lot of passive components on that transistor there that's going to be consuming some current, except it doesn't operate correctly. So no, a 7555 IC is not going to work in place of the 555, which would have something to do with that reset pin, because it's a little bit different to the 555. So I'll stick the 555 back in, if I can get the 7555 out. It was worth a test. I mean, you can substitute the 7555 in some circuits, but not all. Ooh. Now that socket's tight for some reason. I really need to get myself an IC extractor tool, because that's ridiculous. Very ridiculous. I've never come across an IC socket that was that tight. It's not a machined one, it's just a normal 55-cent jobby. I'll put that back in the correct way around. Maybe. There we go. And we're back in business. So, yeah, 10 MA is going to have to be the way it goes. Also, the LED is going to be consuming some of the current as well. So if that LED wasn't there, it'd probably be drawing a lot less. Well, that's it. That works. There's not much else I can do with it. Except drop the voltage down to 9 volt and see if it operates at 9 volts. Current goes down a bit too. Yeah, it does. It's more or less just a bit quieter. Put it back up to 12 volts. It's a lot louder at 12 volts. This can go up to 15 anyway, so I'm going to put him at 13.8. A lot louder. If this was encased in a case, it would be probably a lot louder. So I'll just use one of these containers here. Yeah, it's a bit louder. Anyway, the circuit works for what it is. Does it work that great? No, not really, but it works for what it is. So I'm going to conclude this video here. It was fun to build, and it works. The off time tone is a lot quicker than I would have expected it to be. But yeah, and the kit's $19.95, so it's not that expensive. I had a $10 voucher from JCar, so I went and just paid $9.95 for it. I'm relatively happy with how it performs, because you're really supposed to stick the speaker to the board like that and then mount it in a case. So I may revisit this later and put it in a case. But for now, I'm going to end this video here. If you enjoyed it, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is Yastro30 saying, see you in the next video. Thanks for watching. Ding dong!